Our home's furnace failed on January 1 of 2022. As part of the repair, we got a new thermostat, but now the furnace cycles much too often compared to the old thermostat. And the new one has hardly any hysteresis, they call that deadband. So I wanted to be able to quantify cycle times with the new thermostat and maybe argue with the repair company or the manufacturer for something better. I wanted a totally non-invasive method of measuring furnace cycle time since the furnace and thermostat weren't even close to the desk where I do my stuff. I started with a DHT11 temperature humidity sensor to measure temperature at a furnace floor vent close to my computer while looking for furnace blower on and off cycle rate. I covered this in some detail in part 1. Anyway, I coded up a sketch and got most of the data that I needed, but only after a fair amount of post-processing. That was doable, but fussy to get exact peaks of highs and lows. So I decided to make up a digital quote-unquote wind sensor instead, so I could directly output blower on and blower off intervals. So I got a light beam interrupter breakout board that outputs a 5-volt signal to an Arduino. Next, I made a pivot mechanism and support for a thin brass flag. Lastly, I attached a paper blade to the flag to catch some more wind from the furnace vent. Once I had that mechanism working, I coded up a sketch to send on-change data to the serial monitor. I collect a day's worth of activity as the need arises. At the end of the day, or whatever period I choose, I copy and paste the serial monitor's data into a spreadsheet where I convert it to on, off, and total cycle times, completing the process by producing a simple bar graph. So that's the project for today. Now let's see how the pieces work. Here's the little gadget that got me started on this furnace blower sensing project. It's a light beam opto interrupter breakout board, or photo interrupter breakout board, or, as I bought them, 5 pieces new hot selling motor speed sensor module through beam photoelectric sensor 10 millimeter slot type optocoupler, which cost me 91 cents a piece, by the way, US. There are lots of them available on the internet, and there are often several of them in the printers that most of us have sitting beside our computers. Its output simply switches between 5 volts and ground, depending on whether the little IR beam is broken or not. Here's a side view of my earliest adaptation, using a piece of modeling clay as a counterbalance to the weight of the flag, the white piece of paper. Later on, I replaced the clay with an adjustable length screw for a more permanent solution. Here's a longer shot of the wind sensor. It is simply sitting on a small soup can to catch maximum wind from the furnace duct. I suppose I could improve on this, but this particular furnace duct is over in a corner of the room and in no danger of being dislodged. Besides, the whole setup is, I hope, temporary until I solve the thermostat hysteresis issue to my liking. Here's the current Arduino setup. It's pretty simple, as you can probably see. I'm only using 2 digital pins, one for the signal from the IR photo interrupter board and one for the blue LED that lights up when the furnace blower is on. I include a link to the Arduino IDE code at the end of this video. After capturing a period of data onto the serial monitor, I copy the results and paste the data into a spreadsheet and perform a data/text-to-columns conversion. I know there are many other ways I could have programmed the UNO to send more sophisticated data to the spreadsheet, and I could have written spreadsheet macros to do the conversions. But I just wanted to get the data I needed, but not create a polished product. Here you see the pasted serial monitor data on the left side of the spreadsheet after being converted to columns. Then I grab a range of calculation data and paste it into the sheet in the middle there to give me the answers that I need. And finally, a graph on the right-hand side, which I'll explain in a moment. Here are the actual cell entries that I use to convert the serial monitor data for my use. I guess I really don't even need graphics to get the data that I need or that I want. But I do like the visual impact that they make. So here is but one example of the graphed output. On this particular day, the outside temp increased slower during the morning, the sun came out strong, and then the day turned cloudy. Just for fun, here's a second graph. You can see that the air conditioner's on time increased steadily till mid-afternoon, then slowed as clouds moved in. There you have it. Of course, it's the number of heating cycles per hour that are of most interest to me. So I will have to wait until cold weather hits in central Wisconsin to develop a database for future thermostat choosing decisions. For anyone who is interested, I have a link to the Arduino code on this webpage, https://spaco.org/homeenergy/homeenergy.htm. Thanks for watching.